Hello. Hello students and welcome to this video. In this video we will solve question number 31 to 40 of determinants. The link to download the PDF will be in description, as well as at the end I will show you how you can download the PDF and maintain an updated copy of that. And for connectivity you can see the HTML side of it. I will also show you my question answer website where you can come and ask questions or give answers, which I have created for you because YouTube, it's difficult to type math on YouTube. So without further ado, let's get started. Question 31 says that if A, B, C are the pth, qth, rth terms respectively of an HP, show that the determinant BCP1 CAQ1 ABR1 is equal to 0. So this is the determinant we have to prove to be 0. So we let x to be the first term and d the common difference of the corresponding AP. Then this 4 is extra. Then what will happen is 1 upon a will be the pth term of the AP. So x plus p minus 1 into d. 1b will be x plus q minus 1 into d, and 1 upon c will be x plus r minus 1 into d. So we subtract 1 upon a minus 1 upon b, we get b minus a upon ab, which will be equal to p minus q into d, and c minus b upon dc will be q minus r into d. Now in the given determinant, we apply the operation R1 is equal to R1 minus R2 and R2 is equal to R2 minus R3 to get these two zeros. Okay, and these terms you can see. Now P minus Q, you see from here, we can write this as B minus A upon ABD, and Q minus R we can write from here C minus B upon BCD. So from here we can take B minus A common from the first row and C minus B from the second row. That we take out, we get C 1 upon ABD 0, A 1 upon BCD 0, AB R1. So clearly we will expand along the third column against this R. So this C will get multiplied with this, giving 1 upon BD, and this A will get multiplied with this, giving 1 upon BD. So that will cancel out each other and it will be eventually 0. Question 32 has this determinant. There is no need to read it. Okay, you will see why. So this determinant is equal to px raised to the power 4 qx cube plus rx square plus sx plus t. Be an identity in X where p, q, r, s, t are constants. Find the value of t. So see, we have to find the value of t. So what we can do is, in order to get rid of all this, we put x is equal to 0. So if we put x is equal to 0, these p, q, r, s terms will vanish. So that's what we do here. We put x is equal to 0. The determinant becomes 0 minus 1, 3. 1, 1 minus 4 minus 2, 4, 0. This will be equal to t. So now once we have this determinant, we apply column 3 is equal to column 3 plus 3c2. So 3 plus 3 times minus 1 will be 0. Minus 4 plus 3 times 1 will be minus 1. And 4, 3 are 12. This will become 12. Once we have two zeros, we expand along this minus 1. So it will be how much? 12. 12 here and minus 2. So that will be 10. That will be the value of t. Question 33 says that prove that ABC, a square, b square, c square, a cube, b cube, c cube is equal to abc times a minus b times b minus c times c minus a. So what we do here is we take out a common from the first column, b from second, and c from third. We get abc and this determinant. And this determinant we have evaluated earlier. So that is equal to a minus b into b minus 2 into c minus a. So if you want to see where we have evaluated is, so here, second example. So you can go and watch the previous video to get that. Okay, so that's how we solve 33. Question 34 says that if ABC are in AP, show that x plus 1, x plus 2, x plus a, x plus 2, x plus 3, x plus b, x plus 3, x plus 4, x plus c is equal to 0. So ABC are in AP, so we can write b is equal to a plus 2d and c is equal to a plus 2d. So what we do here is we subtract R3, R2 from R3, that is R3 is equal to R3 minus R2, and R2 is equal to R2 minus R1. So what this will become is 1 1D, and this will be 1 1D. So once we have that, two rows are equal, and therefore the determinant will be 0. Question 35 says that if omega is a complex cube root of unity, prove that 1 omega omega square 1 omega 1 omega square is equal to 0. So what we do here is we do R1 is equal to R1 plus R2 plus R3. We get 1 plus omega square in the top row, which is equal to 0. We know that from the complex root of unity, cube root of unity. So the top row is all zeros, 3 zeros, so the determinant becomes 0. Question 36 says evaluate k, 1, 2, 3, 1, 3, 6. So we take out one common, and then we are left with 1, 1, 1, 1, 2, 3, 1, 3, 6. We do R3 is equal to R3 minus R2, and R2 is equal to R2 minus R1. So we have got two zeros here, and 1, 3 here, and 1, 2 here. Once we have done that, we can expand along the first column. We will get 3 minus 2, 1, that is equal to k. Question 37 says that evaluate a square plus x, b square, c square, a square, b square plus x, c square, a square, b square, c square plus x. So what we do is we do column 1 is equal to column 1 plus column 2 plus column 3. We get a square plus b square plus c square plus x. We take that out. We get 1, 1, 1 in the first column. So others are unchanged. And then we do R3 is equal to R3 minus R1, and R2 is equal to R2 minus R1. So we have this two zeros here, and in this term b square will cancelled. In this one c square will be cancelled. Over here, so R3 is equal to R3 minus R1. So b square will cancel this as well, and x will remain here. So if you expand this, it will be x square. Now a square plus b square plus c square plus x is omitted here. It is a typing mistake. It should be here. So this is the final result of the calculation. Question 38 says that evaluate a b plus c a square, b c plus a b square, c a plus b c square. So we are given this. We do R1 is equal to R1 minus R2, R2 is equal to R2 minus R3. So that gives us a minus b minus c, a square minus b square, b minus c minus b square minus c square, c a plus b c square. So what we do is we take out a minus b out. Let me see. B plus c plus a. So this should be b minus a. We do R1 minus R2. This should be b minus a. Okay, it is mistake here. And this should be c minus b. This is fine. This is a typing mistake. It is a. So we take out a minus b common from the first one and b minus c from the second one. So here we will have 1 1 and a plus b after that, and this would be 1 minus 1. This would be 1 minus 1 and a plus b. This would become 1 1 minus 1 and b plus c. Once we have that, we do R1 is equal to R1 minus R2. We will get two zeros here and a minus c here, because a plus b minus c will be a minus c. Once we have that, we expand along this first row. So this will be a plus b, and this will be plus c. So a plus b plus c. So the final result will be a minus b times b minus c times c minus a times a plus b plus c. Question 39 says that evaluate b plus c, a minus b, a, c plus a, b minus c, b, a plus b, c minus a, c. So what we do here is we do column 1 is equal to column 1 plus column 3. We get a plus b plus c in the first column, all of it. So we take that out, it will become 1 1 1, and then we do R1 is equal to R1 minus R2, and R2 is equal to R2 minus R3. Then we have two zeros here, and we have got this one. So we expand along the first column, that is against this one, and we finally arrive at the result 3abc minus a cube minus b cube minus c cube. Alright, now we come to the last problem, question number 40. It says show that a plus b, b plus c, c plus a, b plus c, c plus a plus b, c plus a plus b, b plus c is equal to minus 2 times a cube plus b cube plus c cube minus 3abc. So what we do is we do column 1 is equal to column 1 plus column 3. The first column will become 2 times a plus b plus c, which we take out, and it is 2 times a plus b plus c. Now once we have that, we do r1 is equal to r1 minus r2 and r2 is equal to r2 minus r3. We get two zeros here, and then we expand along the first column against this one, and we arrive at the result that is trivial to verify, and it is minus 2 times a cube plus b cube plus c cube minus 3abc. So with this, we come to the end of question number 40, and I'll show you the website now. You can come to ashtoker.org, my website. So second, third, and fourth links are PDFs of algebra, trigonometry, and coordinate geometry. You can download those, and those won't contain dates, so you can take the date from here and add it manually. I cannot add the date because if I do that, existing links will become invalid. Coordinate geometry is also in HTML format, which you can read by clicking this HTML format link. And you will need a browser which supports MathML. I will recommend Firefox because Firefox has best MathML support. Chrome, Safari, and Edge will work also. But if you are on a very old computer which has Internet Explorer, it won't work. And it was updated 9th August, that is 3 days ago. And I'll update it today as well. I forgot to update it yesterday. So, and for the question answer website, you can come and ask questions by clicking on its link or going to kunjika.ashtoker.org. You can come here and you can make use of tags like algebra, calculus, geometry, coordinate geometry, probability, mathematics, and trigonometry. So these will help you write math questions. So I have not yet created the help for math, so but it is supported. Okay, MathML is supported using MathJax2. So you can use $$ for inline mode, and so this section will be expanded, and I will add some examples here so that you can type math easily. YouTube comment box is good, but you can't type math. Okay, you can't type alpha, beta, gamma unless you know the Unicode of that and all, or copy paste. So with this, I will end this video here, and we will meet again tomorrow with question number 41 to 50 of determinants. I hope that you have enjoyed and found this video useful. So I'll see you tomorrow in the next one. Till then, stay curious, keep learning, and most importantly, enjoy.